Hello everyone, this is Sanjay from CSIT BAMS. Today my AAT Tech Talk topic of compiler design. Technical perspective, WebAssembly, a quiet revolution of the web. So now we are heading to the topic. WebAssembly represents a significant development in the world of web technologies. It is often described as a quiet revolution because it has the potential to fundamentally change how web applications are developed and run. Here is a technical perspective on WebAssembly's impact on the web. Performance: WebAssembly is designed to execute at near-native speed. It is a binary instruction format that can be executed directly by modern web browsers. This means that web applications can achieve much better performance than traditional JavaScript, which is an interpreted language. Language agnostic: WebAssembly is not tied to a specific programming language. It allows developers to write code in languages like C, C++, Rust, and others, and run it on a web browser. It enables code reuse and integration of existing code bases into web applications. Security: WebAssembly runs in a sandboxed environment within the browser, which means it has limited access to the host system. This enhances security by reducing the attack surface compared to running untrusted JavaScript. Intro Interoperability: WebAssembly can work seamlessly with JavaScript. This means you can use WebAssembly modules alongside your JavaScript code, making it easy to adopt web incrementally. Size and load times: WebAssembly binaries are typically smaller than equivalent JavaScript code. This results in faster load times for web applications, which is crucial for good user experience, especially on mobile devices and in regions with slower internet connections. Offline support: within WebAssembly, web applications can perform complex computations offline, which is useful for progressive web apps and scenarios where connectivity is intermittent. Use cases: WebAssembly is not just for games or computationally intensive applications. It can be used in various domains, including scientific simulations, image and video processing, cryptocurrency, CAD software, and more. Development tools: developers can compile their code to WebAssembly using various tools and frameworks. For example, Emscription and Rust Wasm Pack are popular choices for compiling C, C++, and Rust code respectively. Ecosystem: the WebAssembly ecosystem is growing rapidly with support from major browsers like Chrome, Firefox, Edge, and Safari. This broad support ensures that WebAssembly is a viable technology for web development. The future potential: WebAssembly is not limited to web browsers. It has applications in other environments like server-side execution and embedded systems. It is potentially goes beyond the web. When JavaScript was introduced in 1995, it was intended as a small scripting language for interacting with the HTML DOM. A typical use was validating user form input or making simple animations. For many years, JavaScript programs were mostly small and the majority of the program code in web applications was running on the servers, not in the browsers. This changed with the advent of fast JavaScript engines like V8, which enabled a new generation of web applications executed mostly in the browsers to provide a better user experience. Within the last decade, commonplace JavaScript programs have grown to many thousands of lines of code, and JavaScript is used for far beyond what anyone had anticipated in 1995. Despite the ongoing evolution of the language, it has been stretched to its limits. This has led to people developing compilers from other languages to JavaScript, although JavaScript is horrible as compilation target, and to language extensions and specialized runtime support, in particular ASM.js. Still, JavaScript has maintained a remarkable monopoly, being the only programming language supported by all main browsers until now. The following paper gives us an overview of the initial design of WebAssembly, a new low-level programming language for web-based software. The language has well-defined semantics that ensures program execution to be independent of the underlying hardware and operating system. Browsers routinely run code from untrusted sources, so safety is obviously also an paramount importance. For this reason, WebAssembly is equipped with a type system that prevents certain safety violations at runtime. The paper explains the rationale behind the main design decisions, gives an overview of language, and describe describes preliminary experiences from developing the implementations. No individual features are groundbreaking from a programming language's design point of view. For example, the authors refer to this type of system as embarrassingly simple. The value is in the sum of the design choices. Perhaps the biggest feat is that the WebAssembly team, initiated by the Luke Wagner at Mozilla and Ben Titzer at Google Munch, has managed to unify the browser vendors and coordinate the design and implementation effort. The reader may remember the browser wars where certain browser vendors deliberately undermined standardization efforts in an attempt to gain market share. The paper gives an overview of the formalization, including the operational semantics and the type system. Quite remarkably, the designers have chosen to formally specify the language, which has contributed to the clean design. This approach also demonstrates the power of formal techniques and mechanized language semantics. The essential type safety properties now have machine-checked proofs, which guarantees a solid foundation for the running software. WebAssembly is now supported by all the modern browsers, and it has been embraced by wide range of software companies. The primary goal of WebAssembly is not to replace JavaScript, but to complement it by making it easier to develop computationally demanding web applications, such as games, software for audio and video processing, virtual reality systems, and CAD tools, as well as to port the desktop applications to the web. This is just the first step. The initial of the WebAssembly team has been on compilation from C++, and the first major milestone has reached. The future work will likely concentrate on extending WebAssembly with support for parallel execution, and beyond that, memory management with garbage collection, which will simplify compilation from many high-level programming languages, for example, like Java, C Java, C, Swift, OCaml. Summary. So I summarize that the WebAssembly represents a significant shift in web development, offering a more efficient and flexible way to run code in web browsers. It can improve web application performance, security, and user experience while enabling developers to use a variety of programming languages. As this technology continues to evolve and gain a wider adoption, it has the potential to drive innovation across various domains, making it a quite revolution in the world of the web. So I can summarize that the WebAssembly represents a significant shift in web development, offering a more efficient and flexible way to run code in web browsers. It can improve web application performance, security, and user experiences by enabling the developers to use variety of programming languages. So if this technology continues, they evolve and they gain wider adoption across the web. Thank you.